Okay, this is the March of 2021 Project Wildfire monthly meeting. During this meeting, our topic is the 2020 Labor Day weather and fire event. We'll be hearing from John Saltenberger, meteorologist, the Predictive Services from Northwest Coordination Center. Like all of our meetings, we'll be following this basic format of welcome and introductions, which we do the introductions through the chat box, quite a large group during this meeting. We'll also cover the past minutes in the monthly program update, and then we'll jump into the talk with John Saltenberger, and then we'll conclude with our roundtable updates from everyone and adjourn our meeting. So past minutes were sent out in a previous email and are posted to the web page. If there's edits to those, feel free to contact me with those edits and I'll get them incorporated. So fire free, we've got all of our dates updated to the website that are for folks to find. So if you navigate to fire free and then underneath our fire free events, you'll find this web page with all of our Deschutes County sites and dates, along with everything within Jefferson County and Crook County. Crook County dates have not been announced as of yet. And you'll notice also on here, we don't have Lake County Klamath County this year, as Klamath County was unable to put on the event this year. But you'll also find the flyers here, links to flyers that you can print out and to share across your own networks as you see fit. We're looking to put on a defensible space class here in April. We're looking at April 15th for that class. It'll be a half-day class focusing on the home ignition zone. And then we hope to continue to plan more classes as we progress through the year, depending on the success of this class. And then the last update that I wanted to cover is the Deschutes County Firewise story map. We've shared that before with the group, but we've brought that to a final version at this point and want to get that map out. Here is the final version here. We've got just a few sections that we kind of cover through that, but we cover the need for action. I'm just going to navigate quickly through this. We have a fire history map. It covers some of the history of the fires within Deschutes County. And this is this map will take you on a tour of some of the fires, as there's multiple fires here, but a handful of those you can see a tour of. And then also at any moment you can hit this button in this top right corner, and then you can kind of navigate around and explore some of the fires as you see fit. And when you click on a fire, the bottom left corner will give you a little bit of information about the fire that may be there. And then if you want to go back to the tour, click on that button in the top right corner and you're back in the tour and can continue around on that tour. We have a short session on some of the lessons learned in the past from those fires, and then we've also got another interactive map here of the Firewise sites within Deschutes County. Only a handful of these sites are within that tour. However, similar to the large fire, at any time you can expand it and navigate around to any of the Firewise sites within Deschutes County. And then when you're done looking at the tour or navigating, you can always go back to the tour by that button in the top right corner and continue on. The story map concludes with steps of becoming Firewise. Or the process of becoming Firewise. So that includes the reasons for becoming Firewise, the steps to becoming Firewise, and some of the tools for you to help guide you on your path to becoming Firewise, and some links to some of the resources that can help you down that path and help you become Firewise. Okay, so with those updates, I think we're ready. We're going to go ahead and go to the talk from John Saltenberger, which has already started due to some recording errors that I did, but at this time he's about 2 minutes into his talk, He's still kind of laying the groundwork of basic weather and weather patterns across continental United States, and is about to dive into a little bit more of the specifics of the event of last Labor Day.
Whole host of other weather events. It's the boundaries between air masses that are the most critical places to pay attention to. That transition zone between high and low pressure systems, or cold and warm air masses, that's what I'm paying attention to. And so the next thing I take you to is synoptic scale air masses of North America, which is to say that on a broad basis, I can really identify just a few main air masses that tend to exist over the continent of North America, or oriented north to south and from east to west, or oriented from ocean to continent. And they all have their temperature and moisture characteristics associated with them. As you might expect, air masses that are to the north over the interior of a continent tend to be cold because they're to the north, and they tend to be dry since they're inland over a continent. Contrast that with surrounding air masses that may be cold but also moist because they're over an ocean, or hot because they're further to the south, and dry or moist depending upon whether they're over the continent or the ocean. And it's just a few possible variations between these contrasting air masses that I really have to pay attention to as a weather forecaster. And the reason I say that is because these air masses don't exist in a vacuum. They have their meteorological names that imply their temperature and moisture characteristics. And one of the main identifying characteristics of these air masses, or their characteristics, is that the analogy that I try to use when identifying their temperature and moisture characteristics and the relationship between these different competing air masses is that they routinely jostle against each other. They butt up against each other. And the best analogy that I can use is like a rugby scrum. I mean, these guys are in this scrum, and they're pushing as hard as they possibly can against each other, and they push back and forth. And the boundary between these two different opposing teams, of course, pushes back and forth depending upon who's stronger and who's winning. The same thing happens with these air masses over North America. They push back and forth against each other, and sometimes some win and sometimes others win. And so the important point to pay attention to is the fact that sometimes the North Pacific air mass, the cool and moist one, becomes the dominant one over North America and pushes the others aside. There'll be other times when the warm and moist air mass from the Gulf of Mexico becomes the dominant air mass and shoves the others aside back and forth. Okay, this is the scrum that I'm talking about. Sometimes the warm and dry air mass becomes the dominant air mass and pushes the others aside. And all manner of possible variation. One of the main culprits when it comes to large fire outbreaks that I've seen in the past decade is this one, the cool and dry one that originates over Canada and settles into the United States in various kind of iterations that shoves the other air masses aside. And if I can identify when that shoving is going to occur and when that cool, dry air mass is going to become dominant, I know a lot more about what the fire danger and the potential fire events are going to be. Okay, so drawn in a little bit more realistically, these air masses, they have curved boundaries against each other. And oftentimes we can find that the boundary between these two air masses, there's our word that we were talking about, boundary, transition zone between air masses, is not a gradual change from one to the other. It's an abrupt change. You take one step on one side of that line and you're in a warm and dry air mass. You step on the other side of that line and you're in a cool and dry air mass. And I identify those boundaries by all the tools that I have available to me, which includes looking at temperatures and cloud patterns and moisture and whatnot at various levels of the atmosphere. But if I can identify where those boundaries are and where those boundaries are moving, I know a lot about how the weather is going to change. So meteorologists, of course, draw on the labels for the boundaries between air masses are what we call weather fronts, cold fronts or warm fronts, depending upon which air mass is doing the pushing and in which direction it's moving. And typically, when that cool and dry air mass that originates over Canada and settles south into the United States, they typically move from northwest towards southeast. And that frontal boundary, let's see if I can make this thing move, there we go. That frontal boundary will generally start over Alberta and Saskatchewan and settle down into the central plains of the US, east of the Continental Divide, and kind of push eastward. And that creates the changeability that we see in weather patterns, particularly over the central and eastern United States. And of course, the central part of the United States is most amenable to being under the influence of either the warm, moist air mass or the cool and dry air mass. And it's pushing between those two air masses that results in what we call tornado alley in the central US because of the changeability. But typically, that cold and dry air mass in the spring and the winter and the fall becomes the dominant air mass and shoves the others aside, and day by day creates a dramatic weather change for the central and eastern United States. So when that big high pressure zone moves in from Canada, you can see that it's creating an outward flow, a divergent flow of air at the lower levels of the atmosphere that's spreading out in all directions from that center of that high pressure zone as it moves across the plains toward the eastern US. And typically when that thing is moving from Canada into the United States, pushing strong winds ahead of it in dry conditions, bringing low dew points, we wind up with extreme fire events, red flag warnings and extreme fire events for the eastern United States, which is exactly what we saw over this last weekend, where we had several fires break out in New Jersey that damaged homes with rapidly pushing fires, strong winds, gusty winds, and low humidity. So low dew points, strong winds as that pattern moves in. Now, that cold and dry air mass, it becomes the dominant feature over the central part of the United States when conditions are right for it. And that's what creates the red flag warning conditions for much of the eastern or sections of the eastern United States, depending upon what fire danger is. The other thing to pay attention to with high pressure zones is they already bring dry air with them from the central part of Canada. The other thing they can do, of course, is that weather patterns are three-dimensional. And a high pressure zone is not only creating divergent air that's rotating outwards from the center of a high pressure zone in a clockwise manner, it also brings descending air. So high pressure zones being three-dimensional mean that there's downward pushing air around high pressure zones, which brings even more dry air from the upper atmosphere down into the surface. Upshot being that when these high pressure zones move, they bring very dry conditions, and the edges of them can be very windy depending upon exactly where that thing is lining up and where it's moving towards. Now, the reason these air masses scrum, they push against each other, is related to variations in oscillations in the jet stream in the upper atmosphere, which is why I keep pointing out that there's such an important relationship between air masses at the surface and oscillations and variations in the jet stream. When the jet stream goes through proper contortions, it will determine whether those large-scale high pressure zones in the central United States remain stationary, or whether they move quickly, or whether they move forward or even move backwards. Which is to say that there are times when that strong high pressure zone moving into the central United States will actually start to retreat, what we call retrograde, and move westwards. And now we're getting a contrast between cold and dry inland and warm and dry near the coast, and the boundary between those two oftentimes can be identified as a cold front. And those cold fronts will come out of British Columbia and Alberta and hit Washington, Oregon, and Northern California as that cold and dry air mass starts pushing either from the northeast towards the southwest, and rather than enveloping the eastern United States, envelops the western United States with a cool and dry air mass, with very dry air, descending air with a big high pressure zone coming out of Canada, and envelops the whole western United States. And of course, this is exactly what happened during the Labor Day fire event of 2020, when a cold, dry air mass, very dry air mass, came out of British Columbia and Alberta, settled south over the Northern Rockies and the Pacific Northwest, and pushed all the way as far south as California. It is some variation of this pattern that we're seeing on the screen in front of us that has brought us the rash of Santa Ana fires that we've seen in Southern California over the last few decades. And the strengthening of these patterns has now brought us a resurgence of fires in the central Sierras, resulting in the Camp Fire in 2018 in Northern California. It had also brought us the wine country fires of 2017 over Sonapa and Sonoma counties. And now its most recent iteration, of course, is the Western Oregon, Western Washington fires of 2020. I don't know if there's enough information here for us to determine a trend, but it certainly looks to me like we're seeing what were Santa Ana wind events that were confined to Southern California seem to be becoming more prevalent and moving further north year by year. Whether that's going to be a trend or not, I can't predict. That's longer term stuff than I'm accustomed to trying to forecast, but that seems to be a trend that's moving our way. All right, so that cold and dry air mass, descending air, strong winds associated with that thing. So here's the weather map that identifies our air masses and frontal boundaries as we went into the afternoon of September 7th, Labor Day on 2020. And main features to pay attention to, of course, are the things we've just described. We've got a strong high pressure zone over British Columbia. We have a frontal boundary defining the two air masses, warm and dry over the west coast, cold and dry inland over the northern plains and Canada. And as we moved into September 7th, that frontal boundary pushed out of British Columbia and Alberta, settled over Washington, and then settled over Oregon. And by September 8th on Tuesday, that frontal boundary had pushed all the way down into the Great Basin and was pushing into Arizona and Southern California at that point. So what you can see, of course, going on here is that the air mass has drastically changed as the Canadian cool, dry conditions that I was describing just underneath this high pressure zone become the dominant weather pattern over the much of the western United States. And it's creating a very strong contrast between the high pressure zone inland from that descending mass of cold, dry air inland and the warmer, drier air mass, or the warm, dry air mass over the west coast. And this particularly creates a pattern of contrast between low pressure along the coastline, which I'm showing here with the cursor, and the strong high pressure further inland. All right, this is a classic West Coast high fire danger pattern. This is what brings the Santa Anas to Southern California, brings the Mono winds to Central California, and it brings easterly winds to the Pacific Northwest because of the contrast, the pressure contrast between high and low, and bringing that dry air from inland out to the coast. Okay, so as we move into September 9th, then the high pressure zone becomes the dominant feature throughout the central United States, with just a lingering back high over the northern Rockies and southern British Columbia and Alberta, still contrasting with that low pressure zone along the coastline here. So just as an interest sake, does anybody know, it has a specific name, but does anybody know what that low pressure zone along the coastline is called? It has a very specific pattern. It's called a thermal trough. And you will hear meteorologists talk about thermal troughs, but essentially what it is a narrow, elongated zone of low pressure along the coastline, trapped between some high inland and trapped between another high out over the Gulf of Alaska or the Pacific Ocean. When those thermal troughs set up, they bring their own host of problems, wind being just one of them, in the contrast between high and low. And that's a subject for a future talk that we can do at some point, but it's a component, but not necessarily the only pattern that we saw during the Labor Day fire event. Okay, so this moving satellite image shows the evolution of the cloud patterns as that frontal boundary moved out of Alberta and British Columbia across Washington first and then Oregon during the day on September 7th. And if you just kind of blur your eyes and watch that thing closely, you can actually see the frontal boundary right here as it's pushing out of BC, out of Washington into Oregon. And it's bringing with it very strong gusty winds. It's bringing very low relative humidity and dew points. And the ongoing fires that we had going in Washington and already in Central Oregon at that time, of course, responded to the combination of strong gusty winds coming in with that frontal boundary, as well as the very dry conditions boosting up fire danger. And you can see a number of fires flared up as a result of that, either on flare-ups of ongoing fires or initiation of new ones, particularly in the Columbia Basin of Washington on the morning of Labor Day, September 7th. We had a number of fires make 30-mile runs in light fuels in the Columbia Basin, central Washington, and you can see the fire convection plumes coming up at Washington as a result of that. We can also see flare-ups on ongoing fires in Central Oregon and the Cascades as that frontal boundary moved in. This is why I took such time earlier in this presentation to say that if I can identify where the boundary is between a cold and dry and a warm and dry, that frontal boundary, as that frontal boundary comes across, that's where the gusty winds kick up the strongest. That's where instability in the atmosphere is the worst, and that's where we're most likely to see the combination of extreme fire danger, extreme fire weather events coming together to boost the potential for fires. And that's exactly what we're seeing going on here with this picture. Okay, so this is an event that in my, going on 36 years now is unprecedented in terms of its strength and the suddenness of its arrival and the strength of its winds. I mean, I knew it was going to be a strong wind event as it was showing up, but even with that in mind, I was shocked at just how strong the winds got, even in my home in Clackamas County on the afternoon of September 7th. Okay, so this weather map shows not only the pressure values, there's our big high over British Columbia and our thermal trough along the coast of California. It also shows the dew points in image, the colored image as well. And drier air is marked in browns and moist air is marked in greens. And as we go through the day on Monday, September 7th, middle of the day, Monday, September 7th, come on, there we go, end of the day on Monday, September 7th, you can see the combination of very dry air coming out of Canada plus the extremely strong pressure gradient between the high pressure zone over Alberta, nosing into Washington, and the thermal trough along the coastline. The packing of those pressure values, of course, can be read like a topographic map. The greater the packing of pressure values, the steeper the pressure differential, the stronger the winds are going to be. As you can see, there is a very strong pressure gradient pushing from northeast Washington to southwest Oregon. And of course, that is the culprit behind the strength of the winds that moved first across Washington and then across Oregon on September 7th, September 8th. As we move into the morning of Tuesday, September 8th, the high pressure zone is now descended into western Montana. We have a strong thermal trough along the coastline, and the pressure differential between the two meant that just the wind just accelerated over the Oregon Cascades during the nighttime hours from September 7th to December 8th, reaching unprecedented wind speeds as it pushed in. And in the very dry air, as you can see by the very dark colors, meant that our dew point values dropped down into the teens and single digits, which is unusually low values, especially unusually low being kind of coupled with such strong winds moving in. Okay, so this is a classic inland dry cold front event moving across the Pacific Northwest from north to south, ushering in those strong winds in combination with low relative humidity. A graphic that illustrates the strength of the surface flow pattern at low altitudes scraping above the surface of the earth clearly shows the strong winds coming from the north and the northeast through eastern Washington, through the Columbia River Gorge, and really accelerating out over northwest Oregon and sections of western Washington, depending upon how effective the blocking effect of the Cascade Mountain Range was. Interesting to note that the Cascades themselves have the effect of blocking surface flow in some cases, but also accelerating it in other cases, depending upon how the terrain orientation is working with the wind speed. But we really saw acceleration of wind in the vicinity of the Portland and Salem area where the weather balloon sounding is released, which I'll come to shortly. It's absolutely unprecedented in terms of the wind strength. So there's a graphic that shows during the night of September 7th, 8th, the strength of the pressure gradient from Alberta to southwest Oregon. I've just never seen this many isobars packed into this area any time in my career before. I've seen wintertime events that were nearly as strong as this, but I've never seen one that came during the summer that was this strong. Okay, so here are the maximum wind gusts that were recorded in the 7th, 8th, and 9th for a variety of locations across the Pacific Northwest, depending upon their exposure and the strength of the pressure gradient. We saw plenty of gusts in the 50s, into the 60s and 70s. And of course, that's all related to how the terrain, the orientation of the terrain works with the ambient winds, the synoptic scale winds, pushing across the landscape. But we certainly saw some extreme wind events in central Washington, in the Columbia Gorge, and into southwest Oregon as well, and along the coast as well. And then this is another graphic of the pressure gradient on the morning of September 8th, after the pattern was fully in place, with high pressure over Glacier Park there in Montana, and low pressure along the southwest Oregon coast with the thermal trough. You can see the packing of the pressure values, the isobars, along the east slopes of the Cascades. And again, its value is absolutely unprecedented. This is the equivalent of a meteorological wall in terms of pressure differential. I would say that the effect is comparable to the pressure gradient that was observed over the eastern United States during the perfect storm event that was publicized a couple of decades ago. The difference is absolutely incredible. Of course, this is what resulted in such strong winds that were surfaced in the Cascades, in the Gorge, and in the Coast Range in sections of western Washington and western Oregon. This graphic here is put together by Professor Mass, which essentially shows how strong the winds were as opposed to how strong they normally are, both on the morning of September 7th, when the winds were strongest over central Washington, and then on the morning of September 8th, when the strongest winds had shifted down into southeast Oregon and into northwest Oregon. When we're looking at these gray values, these represent percentile levels of wind strength. And when we're reaching the gray values, we're essentially saying that the wind speeds being observed in the atmosphere were 5 to 6 standard deviations above normal, which is to say that it's just as high as you can possibly measure, given our roughly 50-year record of weather observations over western Oregon and western Washington. So in other words, it was an unprecedented strong wind event. What Professor Mass did was go ahead and he organized reported wind speeds versus wind direction. And so, and then for various events throughout our 50-year record of wind speeds measured at the weather balloon sounding site in Salem. And essentially, the morning of September 8th, Tuesday morning, the wind speed over Salem was roughly 35 miles per hour at the 2,000-foot level in the 2,500-foot level in the atmosphere, roughly 35 miles per hour sustained, which is this much stronger than any of the other winds coming from the east at any other time measured during the 50-year record of winds at Salem, which is to say that this was the strongest east wind event that was observed over Salem in the history that we have. I should say for August and September. There have been stronger winds coming from the west or southwest winds with incoming Pacific storms. But when we look at easterly winds, the dominance of that high pressure zone east of the Cascades pushing winds out to the west side, this was by far the strongest event that we'd ever seen in August and September. Okay, so by the morning of September 8th, the combination of extremely strong winds and low humidities settling into Western Oregon and Western Washington resulted in flare-ups of existing fires. I'm thinking of the Lion's Head fire to begin with, and flare-up on the Beachy Creek fire, but also initiation of new fires in a number of spots in Western and Southwest Oregon during this event. I mention this because one of the fire potential products that we issue from NWC Daily is a potential for new large fires on the landscape. And by doing research into the strength of winds versus fire danger versus initiation of new fires, we have found by and large that throughout history, or at least the history that we analyzed with our analysis, which goes back into the 1980s, is that we do get strong wind events that hit Western Oregon and Western Washington in summer, but typically strong wind events in Western Oregon and Western Washington are not that well associated with initiation of new large fires. Certainly they can cause flare-ups on existing fires, that much is known, but initiation of new large fires is not that necessarily well correlated with strong wind events over Western Oregon and Western Washington. Which is another way of saying is that when we get new fires during east wind events over Western Oregon and Western Washington, initial attack resources are really good at picking up those fires that become large before they become large ones, even when it's windy and dry. This event on Labor Day of 2020 was so strong that it overwhelmed our previous statistics, which is to say that the wind was so strong that it became an initiator of new fires and a propeller of new fires on the landscape, which is relatively unprecedented for us. I've seen a lot of east wind events in the Pacific Northwest in fall or late summer and early fall, and a lot of those failed to do anything other than be windy and dry. Most of the time, windy and dry events in Western Oregon, Western Washington don't result in anything spectacular unless we have already ongoing fires. This was an exception to that. This was such a strong event that it created new fires, probably through downed power lines or escaped campfires. And we wound up with serious new fires on the landscape, a number of which, of course, wound up being spectacular fires with a commensurate loss of resource, loss of life. Background fire danger conditions going into the event, July and August of 2020, we had a broad swath of areas in the affected zones where we had anything between 5 and 25% of normal rainfall for central Washington and much of western and southwestern Oregon. It was very dry going into this event. The drought monitor in effect at the time of the fire flare-ups or fire initiation on September 8th. Of course, we had vast areas of extreme drought being reported in central Oregon, central Washington, and most notably in southwest Oregon. Of our 12 fire danger rating areas and 72 key reporting stations, looking first at the potential for NFDRS indices to represent fire conditions, we at NWC use a couple to track the potential for large fires, and those are mainly keying off of what NFDRS calls a 100-hour dead fuel moisture value or energy release component. We use both of these as gauges of fire danger in our 12 different rating areas. We have found, again, statistically associating large fire outbreaks versus fluctuations in NFDRS indices, that these are the two most associated with large fire outbreaks in our 12 different rating areas. Boone, how are we doing for time here? Are we doing okay? All right.
Yeah.
All right. So looking at how these NFDRS indices fluctuated first in the Columbia Basin during the onset of the wind event, our 30 years of tracking data for three key reporting stations in central Washington. The wind event of September 7th, when we look at wind speed for NFDRS observations, it was the 10th strongest wind event that pushed through central Washington for a 30-year record, but was not the strongest, but it was the 10th strongest. When I look at the NFDRS index called spread component, it was the tied for the 7th highest spread component observed on September 7th as that dry cold front pushed through central Washington. It was also the 10th highest burning index. Spread component and burning index are very closely related to each other. Looking at 100-hour dead fuel moisture values, it was tied for the third lowest. So it was definitely dry out there, although it was not necessarily record dryness. And push onwards here. Now, looking at the fires in Western Oregon and Western Washington during the September 7th and 8th event, again, we're looking at that swath of landscape that had been under that deficit of precipitation, that 5 to 25% of normal precipitation. What I did was combine our PSAs, NW3 and NW4, into one big predictive service rating area that I called 3-4, just for the purposes of our talk today. And it has 16 key reporting stations over 30 seasons of NFDRS reporting data. So looking at our 100-hour dead fuel moisture values for that big 3-4 rating area for the September event, going into fire season 2020, there were several up and down events as weather patterns changed, as conditions got cooler or warmer. 100-hour dead fuel moisture values fluctuated up and down. As you can see, going into early September, we had a nice plunge as conditions warmed up and dried out going into the Labor Day fire event. So 100-hour dead fuel moisture value was low, but it wasn't necessarily at record low at the initiation of the September 7th, September 8th event. And then as the September 7th, September 8th event settled over the area with the strong winds, with the very low dew points and low humidities that moved in with that dry Canadian air mass, it pushed us to record low 100-hour fuel moisture values, which is to say that it was dry going into the event, but it actually didn't reach its record dryness until after the event was already over us. Same is true of 1,000-hour dead fuel moisture values. Some upwards or downwards fluctuations early in the season as we got into cool and wet periods, and then steadied out to settle down to more typical values going into July and early August, and then fell below average going into late August and early September. And then by the Labor Day fire event, we were not at record low values, but getting close to them. And it wasn't until after the event actually settled over us did 1,000-hour fuel moisture values actually reach record low values. So again, the upshot is that going into the Labor Day event, conditions were dry but not extreme, but they did become extreme once the event already settled over us. Energy release component for our big 3-4 reporting area. Again, the 2020 fire season started off slow. Energy release component values were below average through much of May and June and early July. Went near average through much of July, and then went above average starting early in August, with several warm, dry spells where energy release component values spiked upwards according to hot, dry conditions in August. And then going into early September, energy release component values really started pushing upwards quick from mid-August into early September. Okay, this is the dry weather that we saw settling over us during August, leading to energy release component measurements trending ever upwards, reaching about a standard deviation above normal by early September, which is to say it was dry, but it wasn't necessarily at record dryness going into the Labor Day event. It wasn't until we actually got into the Labor Day event itself, as that very dry air came from Canada with the strong winds, did energy release component values equal and then exceed all-time records for those dates in early September. How about other NFDRS indices? Now, I said that what we use to track fire danger through much of Oregon and Washington is mainly keyed upon what we call 100-hour dead fuel moisture or energy release component. But just for interest's sake, I ran some other NFDRS indices for a big PSA in Southwest and Western Oregon. This time I looked at burning index, which is typically more associated with fires in rangelands, fast-moving rangeland fires, as opposed to timber fires. But I decided to run burning index anyway and just have a look at it and see what it showed. And what we found by looking at burning index, it typically varies from low values early in the season when conditions are moist, and it peaks out in August and early September. When I plotted the 2020 values of burning index, just as a gauge as to how strong the winds were and how strong the winds could be as a potential propelling force, burning index reached its absolute all-time record value during the September 7th and September 8th wind events over Western Oregon, because of the combination of high fire danger to begin with and the strong winds overlaid on top of that pushed burning index all the way up to its record values. And so it represented extreme conditions by far during the Labor Day wind event. It's interesting to know because burning index is really not that well correlated with outbreaks of large fires in Western Oregon and Western Washington. Like I said, it's more related to what we see in rangeland type of conditions. But in this case, the combination of high fire danger and the strong winds meant that burning index really did reach extreme values. So my conclusion about how fire danger fluctuated during the Labor Day fire event is that fire danger was high. I mean, we were in a dry spell and fire danger was high and it was climbing. It was about a standard deviation above normal going into the first week of September during the initiation of the event. It was the strongest winds overlaid on top of climbing fire danger that I think really pushed this to being such an extreme event, which is the way Professor Mass has been describing it as, yeah, it was dry, but this was more of a wind event than it was a dryness event. I've seen a lot of cases where we get very dry in September in the Pacific Northwest, but we don't necessarily have a lot of fires. But we overlay very, historically strong winds on top of dry conditions. We got a new beast on our hands, maybe a beast that represents more of what we see in Southern California that gets such combinations of dryness and winds together. I hope that this is not a new trend for the Pacific Northwest, but it may be something that we're going to have to keep our eyes on as we go into following years. And one thing I want to do is recalibrate our fire and potential model as we enter this new era with the new fire danger rating system. The NFDRS latest version of it is more sensitive than the old version, and I want to recalibrate our model to see how the new fire danger rating system works with in conjunction with fluctuation and winds and weather patterns and whatnot, to see if we can draw more value out of it. That's a big deal for us because the entire United States is transitioning into a new fire danger rating system this year, and it will become our operational. In some places it already is operational, and it'll definitely be operational by 2022. Okay, so that's my presentation. Unless anybody has any questions, I'm open to questions.
Great, thank you, John. Yeah, and I would just ask people a couple ways you could ask a question. One, you could pop something in the chat. Another, if you open up the participants, there should be a raise hand function, and we'll go from there. So I see that Dean Richardson has his hand up, so we'll start with Dean.
Yes, John, thank you for the presentation. That was very, very interesting, and kind of a little bit shocking too. My question has to do with the direction of extreme fire danger for our area, Central Oregon. I've always thought during fire season generally it was westerly winds, but it looks like, correct me if I'm mistaken, it looks like in extreme conditions that like the Santa Ana winds in Southern California where they're easterly, that we ended up with that kind of condition in this. And I'm wondering, for preparedness for our communities, a lot of times we've been focusing on fuel reduction, for instance, like to the west of our communities, but it looks like we could get maybe some of the worst kind of fire behavior coming from the east. Is that correct?
You put your finger on a question that I have been wrestling with. I mentioned earlier that I was a caveman in terms of learning new things, which is that I see patterns repeat themselves, and eventually I learn to appreciate what those patterns mean and maybe make an attempt at forecasting. And now we're seeing a new pattern. Now we're seeing something that I have not seen much of in 36 years of forecasting. My main look at weather patterns incoming for Central Oregon always was an approaching cold front coming from the west, or one of these thermal troughs that I've been talking about drifting in, creating hot, dry, windy conditions coming from the west rather than the east. The easterly driven event like the one we've been describing here today was rare. They didn't occur that often, and I mainly associated them with Southern California, Santa Ana wind events. And so I would say that I was less on guard about easterly wind events than westerly wind events for exactly the reasons that you've described. Now, I can't help but notice that in the last few years, I have been shocked by the strength of the winds and dryness during the wine country fires, October 2017. I was struck by the strength and the dryness of the winds during the Paradise Fire in November of 2018. I was shocked by the strength of the winds that we saw during the Labor Day fires over Oregon and Washington. Is that enough to draw a long-term conclusion on? I can't say. We'll have to turn to people like Professor Mass to help us out with that. I would say that based on my experience, the main threat for Central Oregon still remains from the west as opposed to the east, but I'm less confident of that now than I once was. Let me show you something else here. And what I've put on the graphic here in front of us is that pressure map that I was talking about earlier that shows the distribution of air pressure across the Pacific Northwest. And typically, when these high pressure zones move out of Canada and settle into the Columbia Basin or into the Deschutes Basin, the main pressure gradient has been from the Cascade crest out to the coast, meaning during these easterly wind events, Central Oregon and Central Washington they got moderate winds, but not extremely strong winds. The main wind event was spilling over the top of the Cascades down into the west side, through the gorge, to the west side, over the top of the Cascades to the west side, out into the Coast Range on the west side. And I still think that mainly remains the case, is that Central Oregon is not at as much risk of these easterly wind events as they do remain from a westerly wind event. And that's simply predicated upon the fact that these easterly wind events are rare. They're not very common. When they do come, they can be a problem, but it's still the preponderance of wind events that I think that bring to Central Oregon are more westerly wind events, if that helps answer your question.
Thank you very much.
All right, Greg Bryant.
Okay, yeah, my only question was running up to the September 7th event, how many other times would you have seen something similar to what was going on just before that? And then what can we do a day or two? How much of a warning time do we have before something would happen?
Yeah, good question. And I neglected to address this. And something that Professor Mass is really emphasizing in his portion of the paper that we're writing that will be published. And what Professor Mass's point is that this was a well-forecast event. This was well forecasted by the Weather Service with its wind forecast, its relative humidity forecast, and its red flag warnings that were issued several days ahead of time, leading into the September 7th, September 8th event. The numerical weather forecast models did a good job by lining up all the contributing conditions. The forecasters on duty identified that and started mentioning it and putting out warnings for it several days ahead of time. I believe we started seeing fire weather watches coming up on the Friday going into the Labor Day weekend, that an unusual combination of wind and low humidity was headed our way going into the latter half of the Labor Day weekend. And personally, I think the Weather Service did a pretty darn good job of identifying and warning for this event well prior to it actually shaping up. So the answer to your question is, as we get into fire season, as fire danger starts ramping up, and we got to be paying closer and closer attention to our daily forecasts, weather forecasts and fire danger forecasts, as those things come into alignment for these wind events or thunderstorm events or thermal trough events as they all shape up. So I guess, you know, to give the weather forecasters a pat on the back is I think they're doing a pretty darn good job, and the technology and background science is getting better every year. Our forecasts are becoming more and more reliable. It's really up now to the user community, our emergency managers, our fire managers, to be paying attention to the combination of events as they shape up into a potential extreme event as we during each fire, day by day during each fire season. I'm really impressed at how good the forecasting has become, particularly for big events like this. Year by year, the numerical modeling of the atmosphere is getting better. It's their ability to interpret that and relay that to our user base is getting better every year. It's so much better now than when I began my career back in the mid '80s that we're able to do a much better job.
Great, and looks like Boyd Turner also has his hand up.
Hi, good presentation, John. One of the things that struck me was the plot of the BI, and that it was probably, if you put that up against the hauling chart, which I'm sure most of the people here don't really know about, but I'm sure you do, that it's, you know, we're talking those kind of flame lengths that are implied by the BI where firefighters are having difficult or impossible conditions of suppressing the fire. I don't know if you did that, but it seems like that's kind of the next step here in your presentation. But does that kind of imply that we need another warning level where we say, hey, if fires occur today, we're not going to be able to suppress them? And if so, then that kind of comes to as the public service thing of us as the larger group of Project Wildfire to say, hey, look, we have conditions that occur occasionally where the fire folks aren't going to be able to put out the fire, and use that as a tool to help us with our, you know, fuel reduction kind of messages.
It's a very good question and comment, and the reason it really resonates with me, that question resonates with me, is because one of my tours in Australia back in February of 2009, I was there for what's called Black Saturday, which was a similarly extreme combination of high winds and low humidity that hit the state of Victoria in early February of 2009. The event was so unprecedented in magnitude for them, similar to how this was for us, is that the Royal Commission, which studied the aftermath of the fire tragedy in Victoria, recommended that an entirely new class of fire danger be added on top of their existing structure, which was what they called Code Black or Code Catastrophic, on top of their rating system of fire danger. It sounds to me like this is probably exactly the same opportunity for us, as you mentioned, to say that we have such an impending combination of high fire danger and strong winds and low humidity all coming together at the same time, that the hauling chart, or however else we want to measure it, shows us that we're in an entirely new category of fire potential and fire danger. Personally, I can't recommend such a change. I think it's for groups like yours and others to do that. I mention that because with the implementation of the new fire danger rating system, NFDRS 2016, which is just now being phased in this year, the opportunity to make changes over what we historically looked at is there, because we're introducing a new and more sensitive system that may well allow us to better predict such catastrophic combinations coming up into the future, if that answers your question.
Yeah, I think that gets to part of it. I think the other part is that like you kind of alluded to there, is that groups like ours need to kind of take the message to the public that there are these categories of fire where fire suppression is going to be completely ineffective. And I mean, we all know this, but I think we need to use that as a bigger hammer to get the public to recognize that they've got to do some work on their own.
Just to add to that, right? You know, you're touching on a couple good points, Boyd, and one of the things that comes to mind for me when we talk about add another level, when we see these very extreme events, is what would we do in that level that would be different from the point at which we're already hitting the, if you will, the maximum of what we can dispatch to a fire, or the maximum action that we can take. And I think the next step is just what you guys are all kind of hitting around, is that public service announcement, sharing the information out. So like Nathan Garrity put in the chat, he was sending out messages about the weather event, but I think getting people to recognize that when we're talking about these weather events, we might be talking about that next level, like you just said, beyond what we can take really any action on. We've already kind of hit our threshold of like, this is what we have for resources to send. This is the level that we normally see fires getting away and escaping us, but now we're hitting this other level of, we need to make sure no one is starting new fires and have an existing fire on the landscape when something like this moves across us.
Commissioner Adair, did you have?
Yes, if you don't mind, I had a couple comments to make. First off, the fact that this weather event was predicted on September 7th, I do think it was an amazing fact that the Green Ridge fire didn't reignite. I was really worried about that. That was, you know, I could see it out my door. And then unfortunately the Lion's Head did. So that, you know, went over the press, you know, joined up and took out a lot of homes. It was incredibly unfortunate. And then remembering back to the Millie fire on August 11th, that fire started. There was a teeny little plane circling it because I was watching it from Sisters. And then that night there were 35-mile-an-hour winds, which totally blew that up. So one thing, I could say as a victim from, I grew up in Hebner, but I lived in Southern California for a long time. And the one science that I always was amazed by was the ability to actually forecast the wind. And they would say the Santa Anas are going to start Sunday afternoon at 2, and they would, and then they're going to end on Thursday at 3, and they would. I mean, the science is so exact for winds. I do believe there we would get public service announcements saying, okay, they're bringing in extra fire trucks. They believe, you know, this is going to be an event, and, you know, make your better decisions now. But they would always give us a couple days notice. And I think if these winds are going to pick up more, I believe that our community should be made aware of it, especially if you're saying that we're going to have more winds, and I hope we're not, from the Northeast, because it seemed like that wind was, you know, on the 7th of September was incredibly amazing. But no, the accuracy is unbelievable for winds. I think that's the one weather that they don't miss. And I watch the weather report here, and, you know, they'll say, oh, we're going to have snow. We don't have snow. Oh, we're going to have rain. We don't have rain. But when you have winds, you actually, you know, it's something that I believe people should be made aware of it. I've had several fires. One fire actually went around my house in 92, and, you know, 359 homes burned. We knew that wind was going to be blowing that day, and 3 people died. So it's, you know, it's like, we in Deschutes County were so fortunate when we did have the winds on the 7th, that we didn't have a fire start, let's say, you know, up north of 97, where there's a lot of dry brush, and it would have just been blowing. And, you know, you couldn't really even see here because there was so much in the air from, let's say, the Lion's Head fire. I mean, yeah, the skies were totally dark that day. It was quite frightening. So, greatly appreciated your presentation. It was excellent. And now I'm understanding huge channels of weather. And I'm currently reading a document about fires in Alberta, Canada, and what they've learned from their fires. So thank you, John. I appreciate it immensely.
I'm going to pass to Boone some websites that he can distribute to the larger group that the Weather Service put together on the fire events. Nice story timelines that were outlined. what you mentioned, Patty, was why I took pains early in the presentation to talk about the repeatability of weather patterns as they show up. And so, from my perspective as a forecaster, these patterns as they show up, they do repeat themselves pretty closely oftentimes, and they are relatively predictable events for us. So I'm confident that as we go forward, these things are not going to catch us by surprise in terms of our ability to forecast them. Rather, I think our main problem is that marrying up the extremity of a weather event with the extremeness of the fire danger, and then relaying that information to the public in a manner that makes sense to us. We don't want to overwarn, but at the same time, we want to raise awareness. That's going to be the most difficult problem. And in fact, I've heard a number of researchers say that moving forward into the future, that our greatest problem in warning for weather events or natural disasters is less about the technology and the science and more about the human psychology and taking action, sociological.
All right. I would just recognize there's been a couple things in the chat. I know y'all can read them, but Jane just asked of a good place for finding things like fuel moisture values. Boone put a link in there for that. We'll be sure to share anything that John shares with us out to the full group through the notes. And then it looked like Paula Simone also had a question that I think, might have been partially addressed with your previous comment, but she was just wondering how much does go out for the public for them to prepare. And yeah, kind of along those lines, I was also wondering, is there something that's put out maybe at the beginning of fire season that kind of summarizes what all the warnings mean for people?
Let me get Boone in touch with folks from the Weather Service whose job it is to publicize and make clear such publications, and maybe even invite them in to talk about the variety of different types of advisories and warnings that the Weather Service issues regarding these events. I will get Boone in touch with, and I will help facilitate that conversation so that Boone can relay that information to the larger group. I would also, go ahead.
No, go for it, John.
I would also add that this is just one facet. The northeasterly wind events is just one facet of potential extreme fire danger event for us. Given an opportunity, I think we could also review the effect of thermal troughs at some future talk to this group, which is a whole topic in itself.
Yeah, thank you, John, for that. I was going to ask you about thermal troughs, and I was going to do it offline, asking about talking about them, because we see these extreme events, but we want to keep it, still keep it in our mind that the thing that still is more reoccurring that we need to watch out for that happens every year are those thermal troughs that move across us that result in our large fires here in Central Oregon.
Yeah, and I have a couple of presentations I can put together for that to really illustrate the point.
Okay. And then the other piece that I just wanted to mention, Ed and I have talked a little bit about this, but talking about in FDRS, National Fire Danger Rating System, there's changes coming to it, but also there's a lot of things that are clued into it, fire management decisions that happen based on where we progress through the fire season and what indices we're hitting. And I think the piece kind of going back to it is tying in what do we do as far as public service announcement and preparing the general public. We have a lot of tools for managing agencies and getting some information out, but we don't have actionable items, or we don't have a point at which we clearly define when we're going to be increasing our scale of our outreach to general public.
And it looks like maybe we'll end it with one more question from Ray Meow.
Well, thank you, John. Thank you, everybody. Question: if this is a trend where you're seeing these high pressure fronts moving further north, causing the winds to move Santa Ana up to us, what is causing that?
That's beyond my pay grade. I do day-to-day weather forecasting. And try to interpret weather patterns in terms of what they mean for fire potential and fire readiness. Looking at longer term, global changes, that's more of the venue of Professor Mass. who I think will address that in the paper when it does get published sometime this year. Incidentally, when that paper does get published, I'll make sure that Boone knows where to pass it along to the larger group. And that's something that Professor Mass is more qualified to address than I am.
Thank you.
All right, John. Well, I'm sure I can say for the whole group, we really appreciate the time you put into putting this presentation together for us. I'm sure we all learned a lot. I know I did. So thank you for spending some time with us and even entertaining several questions. So we really appreciate it. You're welcome to stick around. We've only got about 10 minutes left, but you're also don't feel compelled to if you got to get off to something else. So with that, we'll close out that section of the meeting. And I would just ask, with the limited amount of time and the number of participants that we have today, I will just call for any updates. We won't do a full roundtable. So again, if you can either raise your hand or put something in the chat, I would just call on folks that have an update that would be beneficial for others to know before we close out our meeting. You can also just come off mute if it looks like we don't have too many people with updates, and share any updates you might have. Dean?
Yes, Ed. I just want to report on Upper Deschutes River communities that I think maybe because of the extreme wildfires we experienced last season, that we've got a great, much greater interest in people applying for and participating in our fuel reduction grants for defensible space. We've got 34 people that have already signed up this year, and we're trying to spread it around as much as we can so that as many individual properties all over approximately 24 communities that we have get something done, and maybe their immediate neighbors see things being done. But we're focusing on trying to use it as an incentive for change, because obviously we can't change the entire landscape with our limited grant funding. But I just wanted to give you that update for Upper Deschutes River communities. Thank you.
Great. Thanks, Dean. And I think it's your website's still up to date with information if people are looking for how to apply for those funds, correct?
That's correct. We have two different programs that we're working for South Deschutes County, and it not only includes the Upper Deschutes River CWPP, but also the Lapine CWPP, and we're running into some unique situations where we're having to kind of tweak it as we go along. But I think the general awareness of the public is increasing as far as what our exposure is. Thanks.
Great, thanks, Dean. Ariel.
Thanks. Yeah, I just wanted to let folks know that Osu Extension is starting to roll out a webinar series called Firewise, Fire Prepared. And so it'll be every other Wednesday at noon lunchtime. It'll be about 45 minutes to an hour webinars, and goes through a whole different series of information about individual and community level preparedness, and also at the landscape scale. And these webinars will be going on through the spring and also pick up again in the fall. And for some folks, maybe a lot of folks here would already have a lot of this knowledge, but there will be more detailed information since there's a lot of webinars involved. But if you know anyone who is at the beginning level, this could also be a great opportunity for them. So I'm going to put the link in the chat if anyone's interested in checking it out. The first one is actually tomorrow at noon. Yeah, thank you.
Great. Yeah, timely update, and definitely, especially for folks that are in communities, I would grab that link and share it out with all your neighbors in your neighborhood.
Thank you, Ed.
Anybody else with anything they want to bring up to the group before we close it out? Okay. All right. Well, we will close out about 5 minutes early then. Not seeing anybody else with update. We will be next month, just as a preview, be diving into an overview of Osu Extension next. And so Ariel will be back on the presentation next month. Osu Extension does have a new fire program, a program focused just on fire, and we'll be learning a little bit about that. And so encourage you to come and learn more about that next month. Thanks all for joining us today, and I hope you have a good rest of your day. Thanks again, John, for joining us. I think people really appreciated this presentation. Have a good day, everybody.